Good afternoon, everybody. Welcome to the Hydraulics and Hydraulic Machines class. In this lecture, we focus on again the problems, but the topic is the force exerted by a jet on a moving unsymmetrical vane. Jet is striking at one end and leaving at the other end. This is the most important case of the impact of jets because this case leads us to the future problems both in turbines and centrifugal pumps. So, from here onwards, you should be very uh, cautious, clear while doing the problems. You should understand first and then ink on paper. So kindly listen carefully when I am solving the problems in this topic. So let us straight away go into the problems on this topic. So this lecture focus on the jet striking a moving unsymmetrical vane. Where the jet is striking, jet striking at one of the tips, not at the center. So the moment I say the jet striking at one of the tips and it is an unsymmetrical vein, immediately what should you should get to your mind is this type of problems can be solved only by drawing the velocity triangles at inlet and outlet. Velocity triangles at inlet and outlet. Then only you can solve the problems. So then what are those velocity triangles? First, suppose I take this is the center line, right? Now I put it as this as the vein, right? Shall I take it? This as the vein, right? Jet is striking, jet is striking like this. This is the way how the jet strikes, right? How the vane is moving is like this, right? This is how the vane moves actually, right? The jet is striking with a velocity v1. So if you call this as inlet tip and this as the outlet tip, then the inlet tip velocity. So naturally, how I am drawing the velocity, if this u, if I represent this velocity of the vane u as u1 at the inlet, u2 at the inlet, finally u1 and u2 are same only, but only for representation, all suffixes 1 represent inlet, suffixes 2 represent outlet. So this is the direction is like this. Now, if I join this actually, and this we call it as VR1. What is V1? Velocity of jet at inlet. What is U1? The velocity of vane at inlet. What is VR1? The relative velocity of jet. VR1 is nothing but the relative velocity of jet. It is relative velocity of jet with respect to vane at the inlet, right? So this is thing. Now how to complete the whole velocity triangles? Now if I take the components of V1 in the horizontal direction and in the vertical direction, if you take it, this is the vertical component of V1. This we call it as VF1. What is VF1? It is the vertical component of V1, right? And what is this horizontal component? So this is the horizontal component of this is the horizontal component of V1. So this VF1 is called as velocity of flow at inlet. VW1 is called velocity of whirl at inlet. Followed? So this is the thing. So then again I am repeating this angle made by this velocity of jet, which is also called as absolute velocity. This angle is called as alpha, and angle made by the relative velocity is theta. So what is alpha? Angle made by absolute velocity with horizontal yet inlet. This is also called as velocity of jet, sorry, angle of angle of jet. Followed? Then the other points also, all inlet I will finish. What is theta? Theta is equal to angle made by VR1 with horizontal. This is called as vane angle. This is jet angle. This is vane angle. And for us, which is important, this is very, very, very important. So finally, with what angle the jet strikes the vane, this is the angle. It is not with V1, it strikes like this actually. So again, after striking it, then how it leaves actually, it leaves like this. This is how it leaves. So the leaving thing, if I take it, it is VR2 because it is entering with VR1, so it leaves also with VR2. I will draw separately that. So finally, if you take this as the outlet tip, so finally, what is the first thing you should draw? This is how VR2 will be. It is tangential to the vane. Then actually, what is U2 direction is always horizontal. So this is U2. Now, if you draw this, if you join this, right, this is what we call it as V2. So this is the outlet triangle. Right now, if you take again the horizontal and vertical components of V2, so this part is VW2 and this part is VF2. VW2, VF2 are only just horizontal and vertical components of V2, right? Then What is the angle? The angle made by velocity, absolute velocity, is alpha and beta, whereas the angle made by relative velocity are theta and phi, right? What is the beta and phi? Beta is angle made by V2 with horizontal. What is phi? Angle made by relative velocity with horizontal. So this is. So finally, what are alpha and beta? Alpha and beta are nothing but they are jet angles at inlet and outlet. And how they are made, these angles are always with respect to V1 or V2, right? Whereas theta and phi are called as vane angles. And these vane angles are always with respect to what? How VR1, VR2 makes with horizontal. So the relative velocities with horizontal is theta and phi vane angles. The absolute velocity with horizontal is alpha, beta, gamma. So these are the things which you should know. So finally, for your understanding sake, once again, I will draw the velocity triangle. So this is V1, then this is U1. Then if you join these two, this is VR1. Uh, to be frank, this is the velocity triangle. That's all. If I take this as A, for example, this as B, this as C, this is the velocity triangle, right? Over. Then angle made by V1 with horizontal is alpha. So this much only you can see here. Understood? Then you for your thing. Then what is this? Take the horizontal and vertical component. What is this? Is the horizontal component, the red one. This is the vertical component. So this one, what we call it as VW1, and this one is VF1. The angle made by VR1 with horizontal is theta. So this is as far as inlet velocity triangle. Then what is the outlet velocity triangle? Outlet velocity triangle, if you take this as the thing, for example, I draw here only. If you take it, so this is how it comes out. Or I will take black only better so that you will be clear. So if you take outlet velocity triangle, this is how it comes out from outlet. This is the outlet point. The outlet point, if I write it as E, for example, it comes out like this. From when it comes out like this, then actually this is relative velocity, right? Then this relative velocity, what is this? This is vane velocity, horizontal always. Then if you join these two, this is V2. So this three, whatever is there, this we call it as velocity triangle at the inlet. The black portions are the velocity triangles. Then if I take the horizontal and vertical component of V2, so this is VW2 and this is VF2. That is extra thing. So now the angles, if I take it, the angle made by the VR2 with horizontal is angle of vane, that is phi, whereas the angle made by V2 is beta, right? That is angle of jet. So this is the outlet velocity triangle. Right? This is, so if this is E, actually if I write it as this is F, because always AB is for absolute velocity, similarly EF is also for absolute velocity, then EF G this is, and this is H, this is D, closed. So finally tell me, ABC is the velocity triangle at inlet, EFG is the velocity triangle at outlet. Here, if you see this beta in this picture, if I observe now, if you see this beta is less than 90 degrees. There are cases where beta can be 90 also. Then in such a case, the outlet velocity triangle, there will be a little bit change. So that also I will show. Suppose this is VR2, right? This is U2, right? Now if I join, beta is 90, I told. So this is V2. Now you see angle made by this will be 90 degrees. So now if such a case basically, so what I can write, the V2 is, there is no horizontal component. So V2 is equal to VF2 and VW2 is equal to 0. If beta is equal to 90, this is beta is equal to 90, right? And always this is 5. And beta is equal to, we already mentioned, 90. So this is the second thing. And third thing that is possible is, so this is VR2, right? This is U2 and this is V2. Now you see this angle V2 make with the horizontal. This beta is greater than 90 degrees. So the velocity triangles, how it changes, you see. Now you want horizontal component, vertical component. So this is the vertical component V2, VF2, and this is the horizontal component, if you see. Right? So this is the thing. So in this case, actually, VW2 will be negative. So that is the only thing you should say. This is beta is greater than 90. So these three velocity triangles are outlet velocity triangles. Three outlet velocity triangle, one inlet velocity triangle. Based on this, what are the formulae that which we have already derived while talking about theory? If you see, number one, the formula is what is Fx. Fx is equal to, if you see, it is rho A VR1 into VW1 plus or minus VW2. This is what we have written. Here the condition is if beta is less than 90, then Fx is equal to rho AVR1 into VW1 plus VW2. If beta is equal to 90 degrees, then Fx is equal to rho AVR1 into VW1, because as VW2 is equal to 0. Then if beta is greater than 90 degrees, Fx is equal to rho A VR1 into VW1 minus VW2. All this I have solved only just for your understanding sake. I am writing it again. Then number two, what is work done is equal to Fx into U, right? Then what is power? Power is equal to work done by 1000 kilowatts. Fourth point, what is efficiency? Output by input. Output by input. Output is work done by input is kinetic energy of jet. Work done is Fx into U divided by half into rho A V1 into V1 square. This is the thing. So if you write all these four, that is the one more also some of the times that will be asked to you. What is work done per second per unit weight of water? This is the thing. In such a case, basically, we should put actually this is work done is how much actually? Work done is rho A VR1 into VW1 plus or minus VW2 into U divided by then work per unit weight of water. Weight of water, how much it will be? It is mass into, we should put mass. What is the mass? Rho A VR1 is the mass. Mass into acceleration due to gravity. So in such a case, because this is nothing but the weight, right? Then answer is rho A VR1, rho A VR1 will cancel. VW1 plus or minus VW2 into U by G. This is the answer. So these are the formulae which I will use. So the inlet velocity triangle is known, outlet velocity triangle is known, formulas four are known. So let us take one problem on this, how the steps are taken. Then I will do in the next class rest of the things. So one problem if I am taking, if you understand that, that is more than sufficient. I will take straight away one problem. A jet of water. Please, why I am writing, I can type quickly and close. But while writing, you understand a jet of water having a velocity of 20 meters per second strikes a curved vane which is moving with a velocity 10 meters per second. Wisdom. The jet makes an angle of 20 degrees with the direction of motion of vane at inlet. Wisdom. Next, and leaves at an angle of 130 degrees to the direction of motion of vane at outlet. Inlet, what is happening? Outlet. That is over. Then calculate. Number one, what he wants? Vane angles. Vane angles means theta phi. Vane angles so that water enters and leaves without shock. That means only no losses. Number two, work done per second per unit weight of water. Striking the vein per second. These are the two questions. Now understand that, then I will take up to you basically the things how we will really make it. Let us go into the solution. Let me see what he has given. So I will first, as it is first problem, I will take first. There are two things: inlet, outlet. So inlet only I will take it. Inlet, what he has mentioned, velocity of jet automatically v1, it is 20 meters per second. What is the other one? Velocity of vane, u1 is equal to 10 meters per second. This what he has given. Then angle made by the jet, that is alpha is equal to 20 degrees, that is over. Then angle made by leaving jet with the direction of motion, so angle made at outlet is equal to 130 degrees. That's what he has given. So what is the thing? So if I draw the things actually just for your understanding sake, one simple things I will draw, just not without complicating. This is center line, right? Now if I take it here as for your, so this is V1, U1, this is VR1, right? This one is VW1, VF1, right? Here it is VR2, then this is U2, then joining is V2, its components are VW2, VF2. So now he has mentioned this is alpha for us, alpha, this is theta for us, and this is phi for us, this is beta. This is what he has given is, you see the question, the angle, the jet leaves at an angle of 130 degrees to the direction of motion of the vane. The motion of the vane is in this direction. This is the direction of motion of vane. The jet makes an angle of 130 degrees. This angle is 130 degrees with the direction of. So if that is the case, what will be beta if this is basically 130 degrees? So this is nothing but actually 130, 180 minus 130. So it will be 50. So therefore beta is equal to 180 minus 130. It will be 50 degrees. So this is 50 degrees and this is basically, you can take it as 90 degrees, then remain. So this beta portion is, you should remember that this is how, this is the direction of motion of wave. Now, if knowing this, let us go forward, right? Let us go how we will take it forward. There is no shock, you told. So U1 is equal to U2. Similarly, VR1 is equal to VR2. How I am able to write these two? Because he mentioned that there is no shock and the entry is so smooth. So both the losses are neglected. So that's how it is made. So now what are the things that we should find out? What is the question that he has put forward for us? Vane angles. Please remember, this is the only way to solve the problems. Vane angles at inlet and outlet. That means what is theta, what is phi? These are the questions. So now let me go with theta, how to solve. So when I am going with theta, I just draw my velocity triangle only at the inlet. I know this is V1, this is U1. See how many times I am drawing it. So this is VR1. Then if I take it, basically the V1 component horizontal and vertical components of V, if you take it, so this is VW1 and this is VW2 and this is alpha and this is theta. What I want? Theta. What should I do for getting theta? If I see the triangles A, if I say it A, AB is always absolute velocity. This is C completion. This is D to end the things. So if I say what is tan theta, you also should do problems like this only when angle means. What is tan theta? Tan theta means basically opposite side, basically, sorry, this is VW1, this is VF1, VF1. Mm. Tan theta is equal to opposite side. That is what? VF1 divided by what is this here? This part, CD part. What is this CD part? Total is VW1 minus AC is U1. So it is VW1 minus U1. So how I got this? Tan theta is equal to PD by CD. It is equal to BD divided by CD is equal to AD minus basically AC. This is how I have written. So this is over. In this, what is VF1? VF1, what I mentioned, it is the vertical component of basically V1. So how I get it? VF1 is equal to V1 sin alpha. Because if you take what is sin alpha is equal to VF1 divided by hypotenuse V1. So that's why VF1 is equal to V1 sin alpha. Or if you write sin alpha is equal to VF1 divided by V1. So therefore VF1 is this. So now if I write V1 is how much he has given, V1 already he has given it as 20 into sin alpha 20 degrees. So first calculation I made is VF1. So this is 6.84 meters per second. Please remember, theta can be found like this only. Then next, after the completion of this, the next one for me is what is VW1? VW1 is nothing but the horizontal component of V1, that is V1 cos alpha, which is equal to 20 into cos 20 degrees. So this is equal to VW1 is equal to 18.794 meters per second. Already U1 is given 10 meters per second. So therefore, tan theta is equal to what I have written, VF1 divided by VW1 minus U1. So it is equal to VF1 is 6.84 divided by, and this is 18.794 minus 10. So if this comes to a conclusion of how much it is getting, 0.7778. So if you calculate what is theta, theta is equal to 37 degrees, 52.5 minutes, right? This is the answer. So one answer is completed. So inlet, this is the only way that you can get the vane angles. Outlet angle, then how to get the what you call it as phi. Phi means vane angle at outlet. So when I have to draw velocity triangle, I know beta is equal to 50 degrees. That is beta is less than 90 degrees. So if that is the case, what is the velocity triangle? So you how is the velocity triangle? So if I draw that actually, so this is VR2, this is U2, and this is basically V2, right? So this angle VR2 is phi because which is what we want. Component of V2 horizontal, component of this. Okay. So this is VF2, this is VW2. So this angle beta. So beta is given already for us. It is 50 degrees. So knowing that what we will do for this, if I write it as E, for example, this is basically E, E, F, G, H. If I take it right from this, how this will be solved, kindly remember. So the moment actually, if this you complete this, how to go into next one? Problem is next one. If I want to go, let me see. For example, so if you take actually EFG, take it, take the triangle. Triangle EFG, if you take it, how to solve phi? My question is how to solve phi. So what I will do is applying sine rule, sine rule. Please remember applying sine rule. What is that sine rule actually? If you take it for example here, so first thing is now if I this is EG is VR2. So VR2 divided by this opposite angle. What is that opposite angle? If I see if this is 180, so this is beta, this will be 180 minus beta. So now what is it? Opposite angle of sine. So because the sine rule is applied, so this side divided by the opposite angle with sine, it is 180 minus beta. This is first is equal to what actually? U2 divided by opposite angle. This angle actually. This angle is how much? If this is 5 for example, right? Now if I take it, this is 5, all these three things to be together basically 180 in a triangle. So finally how much it should be if I see already this is 180 minus b, 180 minus b plus 5 plus this. So this is beta minus 5. Then you see all the summation, you see 5 plus 180 minus beta minus 5 is equal to how much it will be 180 degrees. So that is what we are meaning. So this angle is u2 divided by opposite angle. It is sine of beta minus 5. And the other also I can write. then basically if you take these two angles, from this I have written this, then naturally v2 divided by sine phi, because phi is not known to me. By writing like that I don't achieve anything, so that's why I kept it like that. So that's why I used up to this. But in this beta is known, u2 is known, then beta is known. Unknowns are, two unknowns are there. vr2 is vr2 is still not known, still not known. Phi is same. So what I will do, first one I will try to find out. As he mentioned, there is no shock. VR2 must be equal to VR1. But what is VR1? VR1 I can get from where? Only inlet velocity triangle. Inlet velocity triangle VF1, VR1, how I should get that I should get. So go to inlet velocity triangle, and inlet velocity triangle, you see it. If you see inlet velocity triangle, basically, right? VR1, I want. What is VR1 if I take it? There actually, if I write sine theta is equal to, see the triangle, it is there only in your. Right now, I have drawn that. Sine theta is equal to opposite side, that is VF1 divided by hypotenuse VR1. Already theta I found. Theta, how much I got? 37 degrees. Sine of 37 degrees 52.5 minutes is equal to Vf1. Already I got it. It is nothing but actually V1 into sine alpha. So that how much I got Vf1? Vf1 is equal to 6.84 divided by Vr1. So therefore Vr1 is equal to, I calculated it, and Vr1 is equal to 11.14 meters per second. This you can do it before even drawing the outlet velocity triangle. First time why I did not do that is, why I am calculating, you should know it. So in the second problem, in the outlet velocity triangle, we need to know VR2. How to get VR2? VR2 is equal to VR1. How to get VR1? Go to the inlet velocity triangle and do that. So therefore, I got VR1 is equal to 11.14 meters per second. Naturally, this is also equal to VR2. So now our job, let us take it. What is the thing which we have drawn? Applying sine rule. VR2 divided by sine 180 minus beta is equal to U2 divided by sine beta minus alpha, sorry, beta minus phi. So now very simple. VR2 is known. What is VR2? 11.14 divided by sine beta is 50. 180 minus 50, 30. 180 minus 50, 130. It is sine 130. Okay. Is equal to U2. Already I have given what is U2 is equal to U1. It is 10 divided by sine of 50 degrees minus 5. So this is the thing. So unknown in this is what? Only 5. So if you solve this problem, unknown will be only straight away you can get phi is equal to 6 degrees 33.6 minutes. My only request to you is you calculate actually 11.14 by sine. Basically, this 130 is equal to how much it will be, that you calculate and then put it action this. So this is how it will be. Or 180 minus beta is also nothing but sine beta. This is also equal to sine beta. Anything is right. So put it and then do it. So this is the second one. Right? Theta is over, phi is over. So because the vane angles means this is the only way to solve the problems. Then second question for us is he asked us work done per second per unit weight. This is what I told you also. Unit weight is equal to, already we know it is 1 by G into VW1. Here plus or minus doubt is also cleared because beta is less than 90. So automatically here it is plus, it is VW2. So now you need to calculate these two. Already, let me tell you, VW1 we have already calculated. What is VW1 in the file? This is inlet velocity triangle. It is nothing but V1 cos alpha. It is 18.794 meters per second. Already I did it. What is VW2? VW2 is equal to basically V2 into normally we should put V2 cos phi minus u2. So already cos phi is known. V2 it is VR2. VR2 cos phi minus u2. What is VR2? Already we calculated. VR2 is equal to VR1. So VR2 is equal to, for us, what we calculated is 11.14 is VR2. Cos of phi is just now I calculated. Phi is equal to 6 degrees 56 minutes, right? This is next, minus u2 is equal to 10. So if I calculate VW2, I'm going to get 1.067 meters per second. So VW1 is over, VW2 is over, substitute 1 by G, that means 1 by 9.81 into VW1 is 18.794 minus, sorry, plus 1.067. So if you calculate this, you are going to get 20.24 Newton, basically meters per Newton. This is important. This Newton Y per unit weight we have told. So that's why that. So here I will stop. Once again, I want to tell you two, three things. So these type of questions are only, I cannot do more questions in each thing. So kindly remember that first how we are proceeded. That if you remember, that is more than sufficient. So in any of these questions, in any of the questions related to unsymmetrical single vane, that then naturally you should understand first the velocity triangles. Once the velocity triangles are understood, normally the question will be vane angles. So alpha and beta somehow you can get from the question, if you read properly. Only thing is how to get basically this theta and phi. Theta is very simple, but phi when you are determining, apply sine rule. Take the velocity triangle, apply sine rule, and get the answer from there. So this completes to me one question, and I introduce it to you again the formulae, and then in the next class I will do one or two problems on the same topic, and then we will go into the next topic. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.